Okay, we have been talking the last few classes about arithmetic sequences and series. Recall those are sequences in series where you have the same number added or subtracted to get the next one. What we'll look at right now are geometric sequences. Our goal will be able to write geometric sequences and also find specific terms of geometric sequences. Well, before we do that, we probably ought to talk about and discuss what a geometric sequence is. Again, recall an arithmetic sequence is where we're adding or subtracting the same number to get the next one. A geometric sequence is a sequence in which the ratio of successive terms is the same. The ratio of successive terms is the same. So let's think about what that means. For example, a geometric sequence is 1, 3, 9, 27, and so on. So if you think about the ratio of 3 over 1, that's just 3 to 1, of 9 to 3, well, simplified, that's 3 to 1. 27 over 9, simplified, is 3 to 1. So essentially, what we're doing is multiplying by the same number to get the next term. Where we have a common difference in arithmetic sequences, we have a common ratio, which is the ratio between successive terms. This is denoted by the lowercase letter r. So in our example down here, our common ratio would be 3, because the ratio between 3 to 1 is 3, and so on. Essentially, we're multiplying the first number by 3 to get the next one. We have an explicit formula, just like we do for arithmetic sequences, for geometric sequences that will help us find a specific term. This is t sub n equals t sub 1 times r to the n minus 1. Just like we've had all along, your t sub 1 is the first term. And like we just mentioned, that r is the common ratio. So those are the things that you need to know to be able to use this formula. The first term and the common ratio. So let's look at some examples here. First example says, list the first 4 terms of the geometric sequence defined by t sub 1 equals negative 2 and t sub n equals 4 times t sub n minus 1. So this is a geometric sequence written in a recursive formula. So you can do this a couple different ways. We know, first of all, that our first term is negative 2. So to find the second term, remember that notation sub n minus 1 means the term before. So if I'm looking for the second term, I have to plug in the first term. So this will be 4 times, well, the first term is negative 2. So the second term is negative 8. Take that, plug it in. So now 4 times negative 8 is negative 32. And finally, the fourth term, 4 times negative 32, is negative 128. So the first 4 terms are negative 2, negative 8, negative 32, and negative 128. second example, in a geometric sequence, t sub 1 equals 6 and r equals 4. Find the seventh term. So this is where we are going to use our explicit formula. This is very straightforward considering we're given both pieces of information that we need. So start by writing out your formula. And let's plug in what we know. I'm trying to find t sub 7. The first term is 6 times, the common ratio is 4, to the power n minus 1. If I'm looking for the seventh term, then 7 is my value of n. So let's simplify from there. T sub 7 equals 6 times 4 to the 6th. 4 to the 6th is 4,096. And then multiply that by 6. That's 24,576. So keep in mind that these geometric sequences can grow really big or really small pretty quickly. The bigger that common ratio gets, the faster this is going to grow. So already at the seventh term, we're into the 20,000s, and we started at 6. All right, number 3. If t sub 1 equals 2, and t sub n equals 2 times t sub n minus 1, find the fifth term. So again, we're looking for t sub 5. We're given the first term, but what we need is the common ratio. That's given in our the recursive formula with that 2. So basically what this says is you're multiplying each of the previous terms by 2 to get the next one. So from here, again, it's just a matter of using our explicit formula to find t sub 5. Plugging in 2 for the first term, plugging in 2 also for the common ratio. If I'm looking for the fifth term, my value of n is 5 minus 1. So t sub 5 equals 2 times 2 to the 4th. 2 to the 4th is 16, so 2 times 16, the fifth term is 32. All right, let's take this up a notch to make it a little more challenging. All right, so what we have now, it says find the 10th term. So our end goal is to find t sub 10. Find the 10th term of the geometric sequence where the second term is 48 and the fifth term is 384. All right, the first thing that we need to find is the common ratio. The first thing that we need to find is the common ratio. So here's kind of how I think about this at the beginning. And we did something similar to this with arithmetic sequences and series, but let's set this up. So I have 48 is the second term, then I have the third term, the fourth term, .48 is the second term. The third term we don't know. The fourth term we don't know. And then the fifth term is 384. So what I'm setting up, I'm trying to look at basically how many times did I multiply by the common ratio. So from term 2 to term 3 I multiplied. From term 3 to term 4 I multiplied. from term 4 to term 5, I multiplied. Sorry about the bell. So I multiplied from 48 3 common ratios to get to 384. So what I'm going to set up is from 48, I multiplied by that common ratio 1, 2, 3 times to get to 384. Basically what I'm ending up doing is solving for r. Well, I can write r times r times r as r cubed. We can divide both sides by 48. Gives me r cubed equals 8, and then take the cube root. I get that my common ratio is 2. So I have one of the 2 pieces of information I need, which is that the common ratio is 2. The next thing I need to find is the first term. I need to find the first term. Now, I will tell you, you're given the second term, so to work backwards to the first term would be pretty easy. We would just have to take that 2, divide it to work backwards to the first term. But what I want to show you is how we can use the explicit formula to find the first term in case it's not quite as easy to work backwards. And again, this process is similar to what we did with arithmetic. It's just a matter of using the geometric sequence formula instead. We can choose either one of these terms. I always choose the first one just because it's first, no specific reason. So I'm going to choose the first term to plug in. The actual term is 48, so I'm plugging that into T sub n. I'm looking for the first term. I now know the common ratio is 2, and then the value of n, remember the term is 48, its value of n is 2, so this is 2 minus 1. And then we just solve for T sub 1. So this is 48 equals T sub 1 times 2 to the first. All we really need to do is divide both sides by 2. The first term is 24. At this point, I have the common ratio, I have the first term. Now I can actually use that explicit formula one more time to find the 10th term, which is what I needed in the very beginning. At this point, you could really put that in your calculator. Just be careful that you're entering it correctly. So 2 to the 9th, I would hit enter after that, times 24. This should give you 12,288. All right, I am going to go ahead and do the next one with you because there's something special in this one that I need to talk about. So it says to find the 5th term, so our end goal is to find T sub 5. Find the 5th term of the geometric sequence in which T sub 4 is 768 and T sub 6 is 192. So I'm going to do the same thing. I'm going to set this up. This is T sub 4. There's 1 in between, and then the 6th term is 192. Hang on a second. I'll come find you later. Are you going to be in your room later? What? I already did. Sorry, I'm recording. Otherwise, I'd come talk to you. I'll come find you later. That was Mr. Bruick. He came to see me. Okay, anyway. Sorry about that. So the 4th term is 768. The 5th term we don't know. The 6th term is 192. So from the 4th to the 5th term is one common ratio. From the 5th to the 6th is another common ratio. So from 768 times 2 common ratios, we get 192. This is what I'm doing to find the common ratio. Divide both sides by 768. That gives me 1/4. But here's the deal. When I take the square root, r could be positive or negative 1/2. So that is going to play into finding the fifth term, because we have to account for the fact that we could be multiplying by a positive 1/2 or a negative 1/2. So when we go to find that fifth term, we have to say the fifth term could be a positive 384 or a negative 384, depending on what that common ratio is. We don't really know if it's positive or negative, so we have to say the fifth term could be positive or negative 384, which I got by multiplying by positive 1/2 and a negative 1/2. All right, number 6. Find 3 geometric means between 324 and 4. We're going to set this up the exact same way we've done. So 324, we can act as the first one, and then I have 1, 2, 3 in the middle, then 4 is the last one. So we multiply times 1, 2, 3, 4 common ratios. So 324 times 4 common ratios gives me 4. Divide both sides by 324. And that gives me r to the 4th equals 1/81. We have to take the 4th root of both of these. The 4th root of 1 is a plus or minus 1. The 4th root of 81 is 3. So basically, here's the deal. Anytime you're taking an even root, that's when we need the plus or minus. That is why on, let's see what example. This first example, when we are taking the cube root, it's only positive. It's when we are taking an even root that we need the plus or minus. So let's go through using positive 1/3, multiplying this through. So we're using positive 1/3 to multiply through. So 324 times 1/3 is 108, times a positive 1/3 is 36, times a positive 1/3 is 12, and then times positive 1/3, that would be 4. Let's work through now because we have to do both. Now let's work through with a negative 1/3. So 324 times negative 1/3 is negative 108, times a negative 1/3. Well, that's still positive 36. A negative 108 times a negative 1/3, that's still a positive 36. Times a negative 1/3 is negative 12. Times a positive 1/3, that's 4. So our answer is all of that. Plus or minus 108, positive 36, plus or minus 12. All right, I want you to work on this last one on your own. If you get done with this while you are still in class, I would love to check that.